So what we're going to do today is we're going to start going over the homework assignment. So the first thing I want to do is it says to classify each system by each of the following descriptions: consistent, inconsistent, dependent and or independent, state the number of solutions, and describe the types of lines. So for part A, this is independent because it has one solution. There are intersecting lines. So number one is independent, one intersecting. Number two, we only see a single line. So that makes it dependent, infinitely many, and coinciding. Dependent, infinitely many, coinciding. Number three, your lines are parallel. So therefore it is inconsistent, no solutions, and parallel. Number four, they are intersecting, one solution and independent. Intersecting, one solution, independent. Number five, we have one line, therefore they are dependent, coinciding, infinitely many. Dependent, coinciding, infinitely many. Number six, yours might have been a little trickier because you're in black and white and I is in blue, but the line was here at x equals 3 and x equals 5. So two vertical lines are parallel, therefore no solutions, inconsistent, parallel. Okay, in 7, 8, 9, and 10, we were comparing the equations of the lines, and once again, we were determining which categories they fell into. The easiest way to compare them is to put them in y equals mx plus b form. So you had y equals negative x plus 6. And here we had y equals, you had negative x but divided by 1. So you got x. And then you had plus 6 divided by negative 1. So you had minus 6. So what we notice is that the slopes are opposites. So therefore these are independent, one solution, intersecting. Okay, number 8, first example is in y equals mx plus b. The second example, you have to divide by 2. So you get y equals 1/2 x plus 4. So we notice that they have the same slope and the same y-intercept. That makes them dependent, coinciding, and infinitely many solutions. Number 9, we're going to subtract x and divide by negative 1, leaving me with x minus 3. In number 9, we're going to subtract 1/2 x and divide by negative 3. So you get y equals a positive 1/6 x, and then negative 6 divided by negative 3 is positive 2. So different slopes, different y-intercepts, therefore they are independent, intersecting, one solution. and number 10. Subtract x, divide by -1. Subtract 2x, divide by -2. And we see that the lines have the same slope but different y-intercepts, which makes them inconsistent, parallel, and no solutions. Okay, are there any questions on any of those homework assignments? Any vocabulary words or terminology you didn't understand? Now, I do know on the handout it says to classify as consistent or inconsistent. Consistent is dependent and independent. So inconsistent's parallel, intersecting or coinciding are consistent. So I'm not going to require you to put that. It's just a nice vocabulary word kind of to have. If you used it, make sure you only used it with dependent or independent. Alright, so like I said, we're going to pick up with day 2 today. Today is all about graphing. So when we are graphing, it follows all of the same rules that we followed previously. When we are graphing equations of lines, we like to put our equation in y equals mx plus b. We call y equals mx plus b slope-intercept form because the m is our slope and the b is our y-intercept. Recall that the y-intercept is the point on the y-axis where x is 0. So again, we are looking to kind of put our equations in y equals mx plus b. If the equation is given to you in standard form, so standard form is ax plus by equals c, then you can leave it in standard form. But now, instead of looking for our slope, we are going to look for our x and y intercepts so that we can find our graphs where it crosses the axes. And we can use those 2 points to find our slope. So again, we have 2 goals in mind. We are looking for y equals mx plus b, or we are looking for ax plus by equals c. Once we have our lines graphed, then we're going to follow along and classify them just like we previously classified them in the homework assignment. So our goal is to do what we did in the homework assignment, but now take it one step further and see what these ideas look like graphically. So again, we're going back to graphing linear equations and applying our y-intercepts and b's, and then looking for solutions. So here in example number 1, I have 2x minus y equals -1. As I previously suggested, I think it is the simplest to rewrite that in y equals mx plus b form. So I'm going to subtract 2x and then divide by -1. So minus 2x divided by -1 gives a positive 2x, and -1 divided by -1 gives a positive 1. So I have y equals 2x plus 1. So we're going to first graph this red line. So we're going to start by plotting our y-intercept. So that is at the point 0, 1. And then my slope is up 2 over 1. So we're going to apply our slope. We're going to go up 2 over 1. And then we're going to connect our lines. Remember that when we graph lines, our graphed lines or points are arrowed at the end. So again, you want to make sure that your graph has arrows at the end. Now we're going to graph the second equation. So we're going to subtract 5x, so that leaves 2y equals negative 5x minus 16. And then we need to divide by 2, so that gives y equals negative 5 divided by 2, so that's my slope, x. Negative 16 divided by 2 is negative 8. So we're going to plot our y-intercept. So that's at negative 8. And my slope is down 5 over 2, so I can't see that to the right. So we're going to go up 5 and left 2. Should always have about 3 points. And hopefully what you notice is that these 2 points intersect right here at this point. So we will call that point our solution. So the points negative 2, negative 3. So the solution to this graph is negative 2, negative 3. That makes this graph independent, intersecting. And you can see it has one solution. Okay, let's look at number 2. So once again, subtract 3x, divide by 2, start with your y-intercept, go down 3 and right 2. You can also go up 3 and left 2. Connect your lines. Now let's graph the blue line. Subtract 4x to the other side. Divide by 5. And what we notice in this case, and it's going to be kind of icky either way, is that my y-intercept is a fraction. So what you can do is my x-intercept is not going to be such an icky fraction. So if we zero out y, we have negative 4x plus 5 times 0, which is 0, equals negative 28. So we get x equals 7. So what that means is that this graph, when y is 0, so that's along this line here, x is 7. So what we could do is plot our intercept right here. Now I know my slope, so we can apply our slope to that intercept. So you could go up 4 from any point on your line and over 5, or down 4 over 5, connecting our lines. Once again, we see that the 2 points on the graph intersect, and our solution is that point of intersection right in here. So when x is 2, remember a solution is a point, so we have to write it as a coordinate, negative 4. So the solution to the graph is 2, negative 4. Okay, over here we have our next example. So once again, I can kind of look at these and say I could put in y equals mx plus b. I can leave as is. So if we move it to y equals mx plus b, we have 4y equals positive 8x plus 20. Divide both sides by 4. And we get y equals 8 divided by 4, which is 2, plus 20 divided by 4, which is 5. So what that means is my y-intercept is at a positive 5, and my slope is up 2 over 1. Connecting my points. Graphing my second line. So again, if you want to leave it in standard form, we could see that graphing from standard form. We could find my x-intercept, which occurs when y is 0. So the x-intercept would be negative 4x equals negative 10, or x equals negative 10 divided by negative 4, which is positive 10/4, or 5/2. And then your y-intercept occurs when x is equal to 0. So that would be 2y equals negative 10, or y equals negative 5, which is much easier to graph. I mean, 5/2 is 2.5. It's not terrible. So it goes through -5, goes through 2.5, so really what that tells me is my slope, if you recall, the slope in standard form is -a, so in this case +4, divided by b, which is 2. So that tells me that my slope is a +2. Why is that important? Well, it's important to know my slope because what you need to notice is the slope of equation A and the slope of equation B are both 2. So what that means is when I graph these lines, they should be parallel. That means they will never intersect. That means there is no solution. So again, no solution. And the reason for that is because the lines are parallel. And parallel lines are inconsistent, giving no solution. Number 8, we're going to graph our point. So my y-intercept is a +6. My slope is down 3 over 1. Then we're going to graph the second line. So we have to divide by 2. Plot our y-intercept. And hopefully what you notice is that these two graphs completely overlap. So when red and blue overlap, they make purple, but that also tells me that the solution to this graph is infinitely many, because my lines are coinciding, because they have the same slope and the same y-intercept. So when graphed, I get the exact same line. The graph of the exact same line means infinitely many solutions because any point along this line is a solution. Now it's important to note that this point right here is not a solution. That's not a solution because it's not on the line. So solutions are any points that come from the line. So solutions have to come from the line. Okay, so that kind of concludes our lesson for today. Your homework is extremely similar. You